Okay, welcome back. We're in Chapter 4, Quiz A, question number 2. Let's take a look at the prompt. Suppose that the student taking 22 credit hours in the data set in the previous question was actually taking 28 credit hours instead of 22. So we would replace the 22 in the data set with 28. Indicate whether changing the number of credit hours for that student would make each of the following summary statistics increase, decrease, or stay about the same. So here we're going to change this number 22 to a 28. Well, let's take a look at our calculator. I'm going to go to that list that I had in list 1. I'm going to arrow up to the top. That's an easier way to get to the bottom, believe it or not. And I'm going to change the 22 to a 28. And then I'm going to look at my summary statistics. So I go to Stat, Calculate, One Variable Statistics, and remember, we're talking about credit hours. That is our that's our quantitative variable. Okay, yes, our information is in list 1. And here we go. Here are our summary statistics, our sample mean, our sample standard deviation. We have our minimum value, quartile 1. We can scroll down. Here's our median, quartile 3, and our maximum. So let's take a look at our old values. And compare them to the values that we get when we replaced 22 with the number 28. So here is our original data. Originally, our mean was 16.3, and our new mean is 16.6. Okay, there appears to be an increase in the mean. Our standard deviation in our original data set was 3.7. Our new standard deviation is 4.5. Our minimum stays the same. Quartile 1 stayed the same. Median stayed the same. Quartile 3 stayed the same. Maximum clearly changed. Our maximum was 22 and it increased to 28. So how could we answer this question? Well, first, our mean did in fact increase. And we need to understand that the mean is very susceptible to being pulled in a direction. For example, if there's a large increase in a data set, then the mean is maybe larger than we'd expect it to be. If there's a very, very small value in a data set, the mean may be in fact smaller than we'd expect it to be. So the mean is very susceptible to increasing and decreasing, okay? The median, however, didn't really change. It stayed about the same. In fact, it stayed exactly the same. Okay. The range clearly increased. Our range here was 6. No, I lied. Our range here was 12, 22 minus 10, and now it's 18. So our range clearly increased because we increased our largest value. The interquartile range, which is Q3 minus Q1, 20 minus 14.5, and 20 minus 14.5, that clearly stayed about the same. And finally, the standard deviation. The standard deviation was 3.7. It increased to 4.5. While looking at our calculator, it allowed us to answer these questions. But I'd like to talk a little bit about our distribution. I told you earlier, when we describe our distribution, we're always going to talk about shape. Is it symmetric or roughly symmetric? We're going to talk about center, and the two key words that describe center are mean and median. Those are the two key words that we use to describe center. And then spread. Spread is another key word for us. And the two keywords that we're going to use to represent spread are IQR and standard deviation. Well, there's kind of a method to this madness. The median is associated with the IQR. we use median to describe the center when our data is not symmetric, when there's no real extremes, okay? So median describes the center of a distribution if our data is not symmetric, and the IQR would describe that distribution's spread. The mean, on the other hand, when we have a nice bell-shaped curve, the mean is going to represent our center, and actually, ideally, if we have a bell-shaped curve, the mean, the median, and the mode are roughly the same number. I'm sure you've heard that in class before. And when we represent the mean as our center, we'd always represent standard deviation as our spread. So it's no surprise to us if the mean increases, the standard deviation increases. Okay? Why did the range increase? Well, we increased the largest data value, making the range of values larger. Okay? So again, if we get an increase in the mean, we expect an increase in the standard deviation. That's the variability about the mean. If we get a decrease in the mean, we expect a decrease in the standard deviation. And the median and the interquartile range normally stay about the same and are unaffected, or not completely unaffected, but they stay about the same. They're not really affected by the addition of this 28. So again, when talking about distributions, we want to talk about shape, center, spread. So let's look at a couple of distributions. So let's take a look here. Oh, what happened? Oy vey. Only, I don't know what happens sometimes. Okay, so this distribution here clearly is what we would call a bell-shaped distribution. It is roughly symmetric. If I had to ask you, like, where do you think the center is? You'd say, oh, it's somewhere about here. Okay, I'm not exactly in the center, but it's pretty close. I could see the center visually. If my distribution looks like this bell-shaped curve, or roughly like that bell-shaped curve, I'm going to say it's roughly symmetric, and I'm going to report the mean as my measure of center and the standard deviation as my measure of spread. But if my distribution is skewed, in this case, if I take a look at this graph here, okay, this is called a skewed graph. It has this tail. This is actually skewed to the right. That means that there's a few values that are larger than what's here. And notice the mean is being pulled towards those larger values. Okay? So this would be called a skewed right distribution. And in this case, we would represent the center using the median, and we would represent the spread using the IQR. And finally, let's take a look at this final curve. And this one would be called skewed left. That means there's a couple of data values that are much smaller than the rest. And notice they're pulling the mean towards them. Okay, so again, when we have a distribution that is skewed, we would report the center using the median, and we would report the spread using the IQR. So it's no surprise to me when I look back at the prompt, because I changed a value, I made it larger, and clearly larger than the rest. I mean, some people, 4 people took only 15 credit hours. This is like a double course load, right? So we changed the number of credit hours, then we expected, and we increased the number of credit hours. So we expected an increase in the mean, an increase in the standard deviation, and because we changed our maximum value, that increased the range. And hopefully we've learned that the median and the IQR remain about the same.